Hello, and today I wanted to talk to you a little bit about what is a function. So the first thing we need to know about a function is that typically we're talking about a graph. And if we remember, our graphing coordinates go x, comma, y. So we need to always make sure that we remember that our x comes first and then our y. Now let's take a look at all the words that go with our x. So our x is also known as the domain. It's known as the input. It's the independent variable. And it is the horizontal part of the graph. So if you don't remember that the horizontal goes back and forth this way, then you might want to go ahead and draw a horizontal line there. Now, if we're looking at the y, and we look at the x being the domain, then the range is the y. If the x is the input, then the y is the output. If the independent is the x, the dependent is the y, and the y is on the vertical axis, which means that it goes up and down just like this. All right, let's take a look at what other things we need to know about domain and range. So the domain includes all the numbers that are x values. So all the x values in a function. And the range is all the y values. And when we identify functions, we need to make sure that there is only one value for x for every value of y. So the relationship in which each element of the domain, and if we remember, our domain is our x value, each element of our domain, which is the x, is paired with exactly one element of the range, which is our y. So what that means is when we have a table with x's and y's, and we have 1, 2, 3, 4. Let's say the output for this one is 4, 5, 6, and 7. If you look at the x values, they do not repeat. Each and individual x's has one answer. So the answer for 1 is 4, the answer for 2 is 5, the answer for 3 is 6, and the answer for 4 is 7. So we're going to take a look at some situations where that is not true so we can get a better idea of this concept. All right, functions. What do we need to know? Well, we need to know if it has repeating inputs. So as I was just talking about, we do not want any repeating x's. So if you were going to write anything off of this page, I would write no repeating x's. For example, if I had the function of 2x plus 4 well, it would help if my brain wrote the right thing. 2x plus 4 equals y. I had a table with my x's and my y's. And let's say I'm going to plug in 1 for x. So I would come over here and I would go 2 times x plus 4 equals y. So if I multiply that, 2 times 1 is 2, plus 4 is 6. So my output for 1 would be 6. we know that every single time we plug in 1, we are going to get 6. So what we don't want is a situation where I could also plug in 1 and I could get -6. So if I plug in 1 here, I'm still going to get 6. It equals 6. So this is a function. It would not be a function if I could plug in 1 and get 6, and I could plug in 1 and get -6. We don't usually have 2 answers to a test, just like we don't have 2 answers to a function. The other thing I want to point out to you is the vertical line test, and we're going to talk about that a little later, but I just want to introduce it to you. If I have a graph, and I have a function, I know that it is a function if it passes the vertical line test. So here is my graph. And let's use pink. Here is my line. So that is the line that we just graphed. Now, if I were to take my pencil and draw a vertical line, remember a vertical is going up and down. If I draw a vertical line right here, I'm only going to hit 1 point on the graph. So that would make it a function, but we should always try more than 1. So let's try a different line. If I draw a line here, it is still only going to hit 1 point on the function. So this would be, yes, it is a function. But let's take a look at what it would look like if it was not a function. So if my graph went like this, let's test the vertical line test and see if it works. So if I draw a line here, I'm going to hit 2 points on my graph. I'm going to hit this one, and I'm going to hit this one. So that means I do not have a function. I could even test it again. If I draw a line here, I'm still hitting 2 points. So this would not be a function. All right, clear as mud, right? Let's take a look at what it looks like to have a function in a table and in points. All right, so as we said earlier, we write our points with an x and a y. So when I'm looking at functions, I only want to look at the x values. So let's make a note of that. Look at x values. Okay, so let's look at our x values here. I have 3, 4, 7, and 12. Do any of those numbers repeat? I don't have 2 3s or 2 4s. So yes, this one is a function. But let's take a look at this one over here. I have 2s, I have a 4, and I have a 6, and I have another 2. So I have more than 1, 2. So since my x values repeat, this is not a function. Not a function. So you're looking for repeating x values. All right, let's look at this one. All right, I have 5 and 4, -2, 6, -0, 5, and 1, 3. So let's look at that. I have 5, -2, 0, 1. Do I have any repeating values? Doesn't look like it. So yes, this is a function. And let's look at another example. Let's take a look at this one. All right, let's look. Do I have any repeating values? So I'm going to mark through the y's because right now the y's are not important to me. So look carefully. Do you see any repeating x's? Yep, you're right. The 1's repeat. So I'm going to write repeating x's. So it's not a function. All right, I think that you guys have a pretty good grasp of that. Let's go to the next way a function can be demonstrated. Sometimes a function is demonstrated in a table. Just a simple t-chart, doesn't have to be anything fancy. But again, what are we looking at when we're looking at our functions? We are looking at our x values. So again, I'm just going to cross these out, not wiggle them, cross them out. I'm going to cross these out because these are not important to me right now. And let's look. I have 2, 4, 5, and 7. So yes, I have no repeating values. This is a function. Let's take a look over here. I'm going to cross my y's out. And I want you to look and see what you see. Does anyone see a repeating value? That's right. We have a repeating 3 right here. So this is saying if I plug in the number 3, I'm going to get -3. And if I plug in the number 3, I'm going to get 12. Well, in math, we can't have that. We can't have more than one answer. So this would be not a function because of repeating x's. Let's try that again. Okay, so now let's take a look at another table function. Let's take a look at this one. So I'm not looking at my y's, I'm only looking at my x's. So I'm going to take a look, -20, I don't see any more -20s. I don't see -17. Oh, do I have more than one -17? Looks like it. I have a -17 and I have a -17. So I have 2 repeating x's. So it's not a function. Okay, good job. Let's take a look at maps. Now maps are hard for me. This is one of my least favorite things to look at. All of these arrows typically are very confusing. So let's take a look at this one over here that says that it is a function. If you look at each individual value of x, there is only one line going to each y. So let's put that in a table so we can look at it better. So I have 3 goes with 10. I have 2 goes with 8. I have 1 with 6. 0 with 4. I have -1 with 2. And I have -2 also with 2. Now I know you're saying that we have some repeating here, but let's look at these values. Is this a repeating y value or a repeating x value? That's right, it's over here in my y's, and I don't care about my y's. So this one would, yes, be a function. But let's take a look over here. I'm going to make a t-chart again. I have -2, 3, 4, and 10. Now let's look at what my -2 goes with. It clearly only goes with -1. My 3 goes with 0. My 4 also goes with 0. My 4 goes with 2. And I have another 4 that goes with a 4. And then my 10 goes with 6. So if I look at my x values, I can see that I have 2 4s here and 1 4 here. So this is not a function because there are repeating x values. So sometimes on a map, let's make a note on that, you might want to make a t-chart to look at those values a little better. All right. Now let's take a look at some actual graphs. Remember we talked about the vertical line test. So let's take a look and see what we have here. So if I look at this function that's in blue, I'm going to draw a line here. I only touch 1 point. So far, so good. Let's see, where else shall we draw a line? What if we draw a line here? Still only touching 1 point. And what about over here? Still only touching 1 point. So yes, this guy passes the vertical line test. But let's take a look at this function over here that's kind of a sideways U. If I draw a line here, I'm going to touch this one and this one. So that would be 2 points. And if I draw a line here, I'm also going to touch 2 points on the graph. So because I touch more than 1 point, this is not a function because it did not pass the vertical test. All right, I want to take a look at one more graph. This is kind of an important one because it's important to remember that we need to draw more than one line. So if I draw a line over here, it clearly and easily only touches 1 point on my graph. But I should keep checking because sometimes 1 is not enough. If I draw a line here, it will touch 2 points. So that makes it not a function. So it's important to remember that you have to test the whole function. Because just because it only touched 1 point over here, if there's another place where it can touch 2 points, then that will break the rule. All right, now let's look at some graphs. See if I can make this graph a little bit smaller. So we need to know if this graph right here is a function or not. So the first thing we need to do on any graph is we need to make a t-chart because that's going to help me to see all of my points at one time. I'm going to put the X here and I'm going to put the Y here. And then I'm just going to pick a point. Let's start over here with E. So I'm going to count 1, 2, 3, 4, 5. So that's a -5. 1, 2, 3. -5, 3. And then once I did that, I can label it or I can just mark it off because I'm done with that point. So now let's look at D. 1, 2, 3, 4. This is going to be -4. 1, 2, 3. This is going to be -3. So I know I'm done with this one. And then let's look over here at C. So C, I have 1, 2, 3. And I need to go down 1, 2, 3, 4. So that's going to be a -4. And then for B, I'm going to go 1, 2, 3, 4. Oh, just 4. And then I need to go down 1, 2, 3. So this is 4, -3. And now let's do our last point. 1, 2, 3, 4. 1, 2, 3. Now I can look at my X's and I can look at my Y's and I can see clearly that I have 2 repeating 4s. So this is not a function. Now sometimes your functions are going to have lines or curves that are connected together, and sometimes your functions are just going to have points. So it's important to look at both of those. And that concludes our lesson today on functions. So if you have any questions, let me know. And remember, check your X's, not your Y's.